Hello everybody. Let's see about one important architecture called Autosar, which plays a very pivotal role in ADAS. Now before explaining what is this Autosar and what is the role it plays in ADAS, let's have a brief overview about what is Autosar in the first place. Why has it become such a uh, pivotal architecture in the ADAS context? Alright. What is Autosar? Autosar is an acronym for Automotive Open System Architecture. Autosar is a global development partnership of automotive manufacturers, suppliers and technology companies that collaborate to create and establish an open and standardized software architecture for automotive electronic units. Okay, in case you don't understand this sentence, read this sentence a couple of times. You clearly understand that there is something called consortium, a collaboration of various companies to establish a standardized software architecture for especially for automotive electronic control units. Now coming to objectives of Autosar, what are the various objectives of Autosar? Why was this Autosar created in the first place? First necessity was standardization. Define a common software architecture to improve interoperability across the automotive industry. Next is reusability. The next reusability is enabling software component reuse across different vehicle platforms and OEMs. Okay, understand this, across different vehicle platforms and OEMs. So with the help of this Autosar, you can use the same software component across various OEM applications. Next is scalability. Support different vehicle types and hardware configurations. Okay, so this scalability is extremely important. Next is the maintainability and simplify software updates and upgrades over the vehicle life cycle. And coming to the functional safety, support ISO 26262 compliance for safety critical systems. And next is security, providing mechanisms for secure communication and data protection. Now what is this Autosar architecture overview? Autosar follows a layered architecture to separate hardware independent and hardware independent software programs. So both hardware dependent and hardware independent software components, they follow this layered architecture. The key layers are application layer, software components that implement application specific functionalities like power window control or engine management. So in all these application, software is required, and these comprise of the application layer, the top layer, and software components communicate via virtual function bus, an abstraction for inter ECU communication. Next is runtime environment. Coming to runtime environment, it acts as a middleware between application layer and basic software. It also facilitates communication between SWCs and BSW modules. And next comes the implements Autosar component based software model. Alright, next important layer is basic software. The basic software is further divided into multiple layers like services layer, which further comprises of operating system. Next is the communication stack. This manages all the in-vehicle networks, and memory services. It handles all the non-volatile data storage. Diagnostic services like DCM and DEM, diagnostic event manager, diagnostic communication manager. It supports the UDS, unified diagnostic services, and OBD. Next comes the cryptography and security services, which ensures the secure communication. Now next important layer is ECU abstraction layer. And what is the meaning of abstraction? Abstraction is nothing but it acts as a shield or some kind of how to say blockage or a fort, which ensures that the software or the application does not bypass that particular layer. It abstracts ECU specific hardware details, examples port driver, CAN interface, and PWM driver. Microcontroller abstraction layer. It directly interfaces with microcontroller hardware. It includes MCU drivers, clock, watchdog, and general purpose timer. Next, it also includes the communication driver, CAN, LIN, Ethernet, SPI and I2C. Coming to the memory drivers, flash and EEPROM are two important memory drivers. And last but not the least, the input output drivers like ADC, GPIO and PWM. These are all a part of the microcontroller abstraction layers. Now, in case you don't understand this microcontroller abstraction layers, I strongly recommend you go through a course in Udemy or in YouTube. Also, plenty of videos are there about Udemy. In YouTube, there are some videos from ANSYT Technologies which clearly explains in detail what are all these layers about. Explaining all these things in this tutorial is beyond the scope of this tutorial. As of now, you understand that Autosar is a standardized layer between the application software and the hardware, which ensures smooth working of the software. Unless you are into career into Autosar in your career, this may not be required in depth. You just understand that this is a layer on which application software is added. Now, coming to the complex device drivers, it allows non-standard or performance critical functions and bypasses Autosar layers for direct hardware access. Now, coming to Autosar workflow development process. When it comes to Autosar workflow and development process, system configurations like define ECU requirements, network topology and software components. It also uses Autosar tools like DaVinci, ETAS and Isolor electronic tracer. Especially this vector DaVinci is very popular tool for configure software as per Autosar architecture. Okay, and next comes the software component development. It creates software components with well-defined interfaces, sender, receiver and client server. It also generates RTE interfaces for communication. Okay. Now, coming to the ECU configuration and integration, configuring BSW modules, operating systems or communications or memory diagnostics, it generates ECU specific code using Autosar tools. Now, coming to code generation and build, Autosar compliant code is generated and complied for the target microcontroller unit. So, these are all the various steps involved in Autosar development. And last but not the least, testing and validation. You verify the functionality, timing and safety compliance. In safety compliance of Autosar is nothing but functional safety ISO 26262. Now, Autosar, there are two types of Autosar which are majorly used. One is adaptive Autosar and other is classic Autosar. When it comes to adaptive Autosar and classic Autosar, we will compare the feature, how it fares in Autosar classic and how it fares in the Autosar adaptive. Next is target applications. Hard real-time engine braking, high performance ADAS infotainment. Okay. Now, it comes to execution model, Autosar classic, static scheduling and Autosar adaptive, dynamic scheduling. When it comes to communication, in Autosar classic, CAN, LIN and FlexRay, and when it comes to Autosar adaptive, Ethernet and some IP. Please understand CAN, LIN, FlexRay are relatively slower than Ethernet. Coming to deployment, fixed rate, compile time and dynamic, Autosar adaptive. Safety compliance, ASIL D and ASIL B. So, when it comes to ASIL D, where criticality is very high, then Autosar classic is used, and especially for applications where criticality is less or fatality probability is less, ASIL B and ASIL C adaptive Autosar is used. Okay. Now, coming to the advantages of Autosar, it reduces the development time and cost, because with the help of Autosar you can use the various software components. Alright, it improves the software quality and reliability. It also enables multi-supplier collaboration and it supports future technologies. Example, autonomous driving and electrification. Now, coming to challenges, the main challenge is complexity and steep learning curve, and tool chain dependency requires expensive configuration tools, and overhead is may introduce latency in hard real-time systems. Okay, these are the main challenges. The complexity where learning AutoSAR is very difficult, and tool chain dependency. Configuring software as per AutoSAR is also very complex, and it requires some very expensive configuration tools like DaVinci configurator. And also overhead, it may introduce latency in hard real-time applications. So as especially in ADAS where real-time operation is becoming more and more important, presence of AutoSAR, it may introduce latency, or it may, in other more common words, it may introduce a bit of lag. Now coming to the conclusion, AutoSAR is a critical standard in modern automotive software development, enabling scalability, safety and interoperability. While classic AutoSAR dominates, traditional adaptive AutoSAR is gaining traction for high performance computing in autonomous and connected vehicles. Okay, so understand this. Classic AutoSAR is in traditional vehicles, and adaptive AutoSAR is gaining traction for high performance computing in autonomous and connected vehicles. So you can come to a decent conclusion that adaptive AutoSAR plays a more important role in ADAS, because ADAS is a very important step in moving towards L5 level or autonomous vehicle level. Thank you.